Good morning student, I am Dr. Kruti Jethwa, Associate Professor from Sri Shankaracharya Technical Campus, Bhilai. The course name is Fundamental of Building Construction. This is week 9, lecture number 26 and topic is formwork. Introduction. What is a formwork? The formwork is a temporary structure used in construction to hold and shape freshly placed concrete until it sets and gains sufficient strength to support itself. Or formwork, a mold used to form a concrete into the structural shape. The shape may be beam, column, slab, cells. For the building, it is a crucial component of a concrete structure, ensuring that the final product has a desired shape, size and the finished. Requirement of good formwork. First, the load. It should be adequately strong to withstand extensive variety of dead load and the live loads. For instance, self weight, the weight of a reinforcement, the weight of a wet concrete, loads of a worker and any other loads during and after the casting of a concrete. Second requirement, cost. The material of a formwork should be inexpensive, easily accessible and can be reused for several times. Third requirement, that is strength. Formwork should be strong enough to support all loads applied to it and maintain its shape. It should be raised and tied together from all sides to keep it aligned and prevent it from wrapping and distorting. Fourth requirement, water tightness. The formwork should be watertight to prevent the cement grout from the leaking. It should also be waterproof so it does not absorb water from the concrete. Fifth requirement, removable. The formwork should be easy to remove without damaging the concrete. It should be designed so that the part can be removed in the specific order without damaging the concrete. The formwork can also be designed so that some component remain the part of the finished structure and the rest can be removed without damaging the structures. Sixth requirement, the material. The material should be affordable, easily available, reusable. It should be lightweight to reduce loads on the supports. Flexibility. The formwork should be constructed properly and raised on the firm base on a level surface. It should be fixed in a line and level according to drawing. 8. Inspection. The formwork should be inspected regularly and have a high quality of workmanship. The formwork oil. As we know, the in formwork we have to apply some lubricant material so that it should be easily removed after the construction. So, the formwork oil, the purpose of application of formwork oil to the shuttering surface is to create the separate medium between concrete and the shuttering. It also helps keep the formwork clean and give extra life to the shuttering in terms of more repetition. The formwork oil to be applied 48 hours prior to the concrete in a case of roof concreting and 2 to 3 hours in the case of column and the wall concreting by form gently smeared in oil. It recommended to use branded shuttering oil or a mixture of grease and diesel. The burn machine oil or a used oil is strictly not to be used, which is unsuitable and not only spoil the shuttering surface, also have effect on the concrete surface against the plastering. The process of formwork construction, these are the several steps. First, choosing the material. The material used for formwork should be sturdily enough to hold the weight of the concrete. Popular material include wood, steel, plastic, foam, etc. Manufacturing. The formwork can be manufactured using the process such as drying, gluing, molding and trimming. Erecting. The formwork is erected and raised to provide stability during the assembly, pouring and curing stage. Scaffolding can be used to support the formwork, especially for elevated building and the bridge. Pouring concrete. Fresh made concrete is poured into the formwork. Removing formwork, the formwork is removed safely so that the concrete can be accessed. Component of formworks, these are the some parts which we will use for the formworks. Some members may be horizontal, some members may be vertical, some member may be diagonal, some bolts, some nuts, some working platforms. So, some components we are going to discuss here. These are the components of the frameworks. First, a tie. Tie is a tensile unit used to connect opposite sides of the formwork. It serves as a balance connection, or it's used to resist effective pressure or a fresh concrete. Raised are used to keep the formwork upright by deterring the deflection under the lateral pressure. Studs in the formwork are used to support the seating plate panels and make the formwork to keep them in position. The seating panel is used to keep the concrete in its desired shape and position until it sets and hardens. Another parts, the wales. The wales are the horizontal propping members that are placed against the sittings to the direct resist the shearing sitting pressure. Battens. The battens are the vertical members in the formwork which keep cleats and the wales upright and in position. Footing is the bottommost member which supports the entire framework. These are the components of a framework, which include the battens, races, ties, studs, seating, wales, footing. This photograph clearly shows the position of each and every components. The history of formworks. In ancient civilization, they used the simple formwork techniques such as wooden molds. In 19th century, introduced the steel formwork for the large structure. Early 20th century developed the aluminum and the plastic formwork. Mid 20th century introduced the engineering formwork and insulated concrete formwork system, and the present day continuously evolving with a advancement in the material and the technologies. The first type of formwork we are going to discuss, that is timber formworks. The timber formwork is the most common types among all formworks. Timber forms are extensively used in the construction since the ancient periods. The timber formworks is the oldest types of form used in the construction. Timber formwork is most used in construction amongst all other types of formworks. It's often on-site fabrication of the required shape and size. It's easily used in any construction, but it may provide time consuming for a large project. Plywood formwork material has a short lifespan. Timber shuttering is a low cost and easily workable shuttering. It can be cut and joined in any shape and size. Requirement of timber formworks: it's light in weight, it's properly seasoned, it means it should be dry. Third, free from any termite attacks, easily workable. Advantage of timber formworks: timber shuttering is easy to form any shape, size and height. It is proven economically for a small project. It can made using a locally available timber. Timber is light in weight compared to steel and aluminum shuttering. Disadvantage of a timber formwork: impure cured timber may absorb the water from concrete and reduce the structure strength. High moisture timber can cause cracks in the concrete member and lead to leakage in the joints. The life of a timbers is not long, low reusability and not environmental friendly. Second type formwork, steel formworks. Steel formworks has become more popular due to the strength, durability, repetitive use for a long period. Steel formwork is costly for a small work, but it can be used for a large number of projects. Steel shuttering offer a smooth surface finish to concrete compared to timber formwork. It can be used for circular, curved structures such as tank, column, chimney, shivers, tunnels and the retaining walls. Advantage and disadvantage. Advantage: it is strong, durable and long life. It's offer a smooth finish to the surface of a members. It is completely waterproof or moisture proof and minimize the honey combining effect. It can be reused for more than 100 times. Steel formwork can be fixed and removed with a greater ease. Disadvantage: economy. Steel formwork is better suited for the large budget project due to the high material costing. Weight: disadvantage is weight. The formwork is heavy and require the assistance of machinery and lifting the equipments. Corrosion: the maintenance of a steel formworks form a corrosion due to excess water contact unnecessary for durability. And limited molding: the steel formwork has restricted shape and the size. This is another steel formworks for the column work. Another type material, that is aluminum formwork. As we know that density of aluminum is less compared to steel and it makes it lighter weight than the steel. This is the main advantage when compared to the steel. The aluminum formwork is almost the same as formwork made from the steel. Shuttering down with aluminum formwork is proven economical if a large number of repeating usage are made in the construction. Its a major drawback is no alteration is possible once the formwork is constructed. Advantage using the aluminum formwork: economy. All our cost per square feet of aluminum formwork is much less as compared to the conventional type of formworks material due to highly reusability factors. The erection process can be executed even by the unskilled labor without incurring high cost of hoisting cranes or lifting equipment. Time. The feature like easy mobility, adaptability, no plastering and the simultaneously casting of a slabs walls reduce the construction time to 2/3 of the total time. Eco-friendly, zero usage of timbers, manifold reusability makes it environmental friendly. The resulting structure are earthquake resistant. Finishing. The super wall finishing save the finishing time and the cost of the plastering material. Other advantage: custom designing, reusability in case of the repetition of the floor layouts, monolithic crank free structures and low maintenance. Disadvantage of aluminum formworks: the architectural modification of the structure are not possible after fabrication. The initial costs can be over budget in the case of small projects. The precision in the alignment and the safety standard require a short training for laborers to get equipped with the whole process. Another, plywood formworks. The plywood formwork is one of the remold timber resin bonded plywood sheet attached to the timber frames to make up panels of a required size. It's strong, flexible and easy to handle. Its life is too short compared to other materials. Fabric formworks. With the advance and the new technology trends in building planning and designing, the construction of complex shapes structure member is increased. To satisfy these needs, the fabric formwork is introduced with a make the flexibility in the material make it possible to produce concrete in any shape. The flexibility of a fabric formwork make it possible to produce concrete member of any shape. Plastic formworks. The plastic formworks are lightweight, interlocking systems and can be used more than 100 times. It can be used for a normal concrete construction. This type of formwork is now becoming popular for the similar shapes and the large housing systems. Advantage of plastic formworks. The plastic formworks are light in weights and hence require high handling cost. It can be utilized in a large construction section. If careful installation and the use and the multiple reuses are possible, make it highly economical. Disadvantage: require pre-planning and designing as field fabrication is not possible. Depending upon the class and the durability of chosen plastic material, it can be little expensive. Require a special attention to heat damage from the accelerated curing of a concrete poured in the formwork and the less load endurance than the other type of a formwork in the construction. The advantage of prefabricated structures. So, some structures are available prefabricated for the formworks. So, these are the there's some advantage like money and the timing and the durability. So, we're going to discuss each and every here. First, save construction time and the money. One of the most significant advantage of prefabrication is that it's allowed so faster construction than the traditional method, because all the elements are partially produced, just assemble and connect of the parts take place at the development site, saving the time. Cost effective. The prefab house are comparatively cost effective while traditional building costs continue to rise. It's make use of low cost basic materials such as terrace brick, flooring, ceiling and the plaster boards. Because of low cost, several developers have begun to use prefabricated component in their projects. Another advantage, reduce the environmental stresses. The building industry is the world's leading popular. The high pace of the building activity along with inadequate raw material selection significantly contributed to the environment concern. The major building material, burnt bricks, is a primary source of air pollution and the greenhouse gases emission. Contribution of 170 billions brick yearly, consuming roughly 24 million tons of coal and produce 61.3 million ton of CO2. According to the TERI study, the green growth and the building industry in India 2015, moreover the cement, steel are the two essential elements that contribute to greenhouse emissions. The disadvantage of prefabricated houses, first the planning take longer. While the building and assembly, the prefab property may be quick and the planning phase is generally lengthy. Locating the property, hiring a contractor and preparing the sites all takes a significant amount of time and efforts. Problem with quality. One of the most well-known disadvantage of prefabricated buildings is that they do not provide a same degree of quality as a conventional structure. These approaches are restricted in the term of customization and service regions. The forms of formworks, that is a wall formworks, slab formworks, beam formworks, column formworks, stair formworks. Wall formworks for the vertical structures such as wall and column. Slab formworks for horizontal structures such as floors and ceilings. Beam formworks for linear structures such as beam and girders. Column formworks for vertical columns and the piers. And the stair formwork for the staircase and the landings. Forms of formworks, first for wall formworks. Wall formwork can be made of timber, steel, aluminum and other material. Steel and the aluminum wall formworks are typically prefabricated to particular specification and can be reused several times after the first use. Wall formwork is often modular and come in various shape, size, design and configuration. It can be adjusted individually to adapt to a complex shape and the high loads. Generally, the concrete building structure with a high requirement on the surface and the anchoring pattern can be effectively realized using the frame wall formworks. The application of the wall formwork system, it is used for the industrial residential building, load bearing walls, reservoir construction, shear wall construction, basing construction, corner wall construction, foundation wall construction in existing building, bridge embedment, wall construction. This is the wall formworks. These are the some materials used, that is a parts, that is vertical post, horizontal member, rackers, stakes and the wedges. The formwork for the wall, it's a construction steps. The following figures show the fixed form of walls. Boarding may be 4 to 5 centimeter thick wall up to 3 to 4 meter heights. The boards are fixed to 5 cross 10 centimeter post. It's known as a studs or soldiers. Space at about 0.8 meters apart, horizontal walling of size 7.5 centimeter cross 10 centimeter are fixed to the post at suitable interval. The whole assembly is then shuttered as shown using 7.5 cross 10 centimeter strut. The two shutters are kept apart equal of thickness of a wall by providing 5 centimeter high concrete clinker at a bottom by 2.5 cross 5 centimeter space nailed to the post. Second type of sketch show the moving form for a wall. The forms are made up of panel size of 0.6 meter cross 1.8 meter so that handling and the strippings is easier. A 15 mm plywood is commonly used instead of boardings. The panels are erected in such a way that the lower panel can be removed when concrete is hard and used higher up the wall. The framing of size 5 cross 10 centimeter used in the ply shutters. The panel are fixed to central of two end studs. Each stud consists of two pieces of timbers 5 centimeters or 50 centimeter block apart. The end studs of each panel secure the adjacent panel. The boards are reserved for a first lift for the succeeding lift, and the bolts pass through the holes from to previous lift. The rapid construction of constant thickness wall continuously rising, the commonly known as a sliding shutter is used. The shutter may rise of 15 to 30 centimeter per hour depending upon the rate of hardening of concrete. Either a hydraulic jack or a manually operated screw jack may be used for raising the form. These are the two photographs for the fixed formwork for a wall or a moving formwork for the walls. This is another type formworks, that is for slab. The concrete slab construction process include the preparation of formwork, compaction of a slab bed, placement of a reinforcement pouring, compacting, finishing the concrete, removing the formwork and the curing the concrete slabs. Steps involves. The following figures show the formwork for a beam and the slab force. The slab is continuously over a number of beam. The slab is supported on 2.5 centimeter thick sheathing laid parallel to the main beam. The sheathing is supporting on the wood batten which are laid between the beams at some suitable spacing in order to reduce to deflection. The batten may be propped at the middle of a span through the joist. The sides form of a beam consist of 3 centimeter thick sheathing. The bottom sheathing of a beam form may be 5 to 7 centimeter thick. The ends of a battens are supported on the ledgers which is fixed to the cleats throughout the length. The cleat of 10 centimeter cross 2 centimeter to 3 centimeters are fixed to the side form at the same spacing as that of the batten, so that the batten may be fixed to them. The beam form to support on the head tree, the shore or a post of a connected to the head trees through the cleats. At the bottom of a shares, two wedge of a hard wood are provided over the sole piece. Formworks for the stairs. It consists of vertical and inclined post, inclined members, wooden planks, sitting, string and the rise plank. Construction details. Figures show the formwork for the stairs. The sitting or a deck for the deck slabs is carried on the cross joist which are in the turn supports on the racking ladders. The ladders is generally 7.5 cross 10 centimeter size. The cross joints may be 5 centimeter cross 5 centimeter size, suitably spaced. The riser plank are 4 to 5 centimeter thick and equal to the height of riser. These planks are beveled at the bottom to permit the hole or to treat face troweled. The riser plank are placed only after the reinforcement fix on the position. The outer end of the rafter is carried by the cutting the string made of 5 centimeter thick plank. Column formwork. The column formwork is to be designed to able to accommodate relatively high fresh concrete pressure as comparatively small cross section are concreted quickly. Therefore, the joints in the particular are to be formed very carefully and tightly sealed. The construction type here, the shuttering of for a column is probably the simplest. It consists of the following main component: sitting all over the column periphery, side yokes and the end yokes, wedge, bolts with the washers. Figures show the formwork of a square column, the side yokes and the end yokes of a number each and the are suitable space along the heights of the column. Two side yokes are comparatively of a higher section and they connected together by long bolt of 16 mm dia. Four wedges, one at each corners, are inserted between the bolts and the end yokes. The sheeting is nailed to the yokes. This is a column formworks photographs. These are the top view or a cross section of a square, octagonal or a circular column formworks. The construction of concrete formworks. The construction of concrete formworks involve the several steps to create temporary structures that shapes and the supports the porous concrete until it sets and gain the sufficient strength. Here is a all over process: first designing and planning, determining the formwork dimension and layout based on drawing, material selection, choose the suitable material for the formwork, preparation of formwork component, cut and treat the panel, fabricate the additional component and the foundation, prepare, level and stabilize the ground floor. That is the construction of a concrete formwork steps. Another, assembly of formworks: erect and connect the formwork component securely, reinforcement placed, install a steel reinforcement with a formwork, alignment and the leveling, ensure the formwork is aligned and level, racing and the supports, provide adequate supports and the racing for the formworks, formwork inspection, check the defects and rectify any issue, concrete pouring, carefully pour the concrete into the formwork, concrete curing, allow the concrete to cure by applying proper water. Curing, what is curing? Curing is a process to maintaining the moisture and temperature of a freshly poured concrete that helps in harden and reach its full strength. Curing is important for a concrete process because it prevents cracks. Curing helps concrete to develop strength and toughness against the cracking. Improve the durability. Curing help concrete develop a dense durable structures. Enhance the abrasion resistance. Curing improve the serviceability of a concrete by making it more resistant to abrasion. Improve the microstructure. Curing help the concrete develop better hydrate gel and the solid mass. De-shuttering is done after the curing. This is the curing process by which we apply the water on any concrete structure and the concrete will gain the strength. Now, after curing, de-shuttering is done. De-shuttering means removal of a formworks. So, it is just a removal of a formwork, the process that it should be carried out after the concrete has gained enough strength. Concrete should be at least twice as strong as it when formwork is removed. Here are some tips for the de-shuttering. Remove the nails and screw first. Take out all the nails and screw that hold the boards together. Second, loosen the form. Gently tap the top and the side of a board with a hammers to loose it. Pull away the boards. Pull the boards away from the slab, being carefully not to be damage the concrete. Use a wedges or a pray bar. If needed, use a wooden wedges or a pray bar to separate the formwork from the slab. These are the de-shuttering timing. As per our IS 456-2000, the de-shuttering timing for a column is after 12 hours, slab less than 5 meters span 7 days, beam that is 14 days, slabs for a span greater than 6 meter as per the consultant instruction. This is the formwork for the tunnel. These are the 7 steps for the formwork in the tunnel. First, the prefabricated wall reinforcement is placed by a crane along the entire wing prior to the casting the kickers. Second stage, the 2.5 tunnel is craned into the place, bolt together and the ties are added. Third stage, the wall concrete is 4. Fourth stage, slab reinforcement are fixed. Fifth step, the slab concreting is placed. Sixth step, the tunnel forms are removed next day. And the seventh step, the process is prepared by for the next two bays. Tunnel form can be produced strong and durable in situ cellular structure. This method of construction can be achieved time saving up to 25% with a cost saving of 15%. Since the concrete finish is very good, the requirement for a post construction trends such as the plasters and the electricians are the greatly reduced. This is the erection of a tower using the slip form technologies. So, slip form technology is used for the longer towers. Here are the procedure. Assembly can be only the start once the foundation are placed and wall starters is in correct alignment. Slip platform shutter is aligned with the help of the yokes. The horizontal cross beam connect these yokes. The hydraulic jacks are attached to this cross beam for simultaneously upward movements. The height of slip range from 1.1 to 1.5 meters. The yoke and the cross beams also be used to support the working platform. The structure should be rigid and maintain shape of all the times. Make sure that there is no legs or else it prevents the structures form free upward movements. It also possible to reduce a wall thickness as the construction gain height and arrangements have to be made in a slip form structure that will enable such as reduction at regular interval. Another formworks for the chimneys, it is used for slip formworks and the jump formworks. It is a combination of two formworks we use. The slip formworks is the construction technique that allows the continuous and slimless pouring the concrete to create the vertical structure like walls, column and tower. It involves the vertical moving the formwork system in gradually rise as the concrete sets. The method eliminates the needs for traditional formworks and the manual labor, saving the time, cost. Slip formworks ensure the high degree of precision and uniformity in the finished structure, resulting in smooth and durable surface. Self-climbing formwork system that is used to building the concrete structure like chimney, silos, stacks. The jump formwork is characterized by the series of step-by-step jumps, where the next section is only built after the concrete in the previous section has set. The causes of failure of the formworks. First, formwork is not designed for a specific purpose, load calculation not accurately, not designed to take horizontal truss in the consideration, not adopting the proper stripping, early stripping, neglecting the shore removal. Example, by removing the free and cantilever portion first instead of fixed end of a cantilever portion first. Causes of failure continuously. Next, inadequate diagonal bracing and the improper packing for vertical prop at the bottom instead of base plate due to unable to withstand the vibration force. Unstable soil under the props, that base plate not maintaining the plumps of a shoring and giving the slant supports. Inadequate control of a concrete placement over the slab, beam, cantilever. Next, lack of attention for a formworks detail, altering the welder supplies material. Next, failures. Uses of damaged elements like loosened welded joints for the across span, broken U-clamps, slippery wedges, etc. and improper vibration in the compaction of a concrete. Safety precaution in the formworks. Install the shoring correctly, use proper formwork tiles, inspect equipment regularly, provide adequate working space, use the guardrails, protect the workers from the wet concrete, protect the worker from the silica dust, develop the emergency response plan, conduct the assessment, access the ladders properly. Maintenance of a formworks. Due to the continuous use of plank wood, steel plates, the surface become uneven and require maintenance. For the wooden formworks, use cardboard or plastic fiber boards. Bolt hole placed must be repaired. Avoid the direct sunlight on the timbers. Use steel formwork. Plate must be level by mallet and the loosened corners must be welded. Apply oil to prevent rusting. Cost of formworks. The cost of formworks is approximately 30 to 40% of the cost of the concrete work of a regular structural work. In case of special structure like flyover, underpass, bridge, tall chimney, dams, etc., the cost will go up to the 50%. Now, shuttering work should be made of a cost effective material, fabrication and the labor as far as possible. After its usage, immediately shuttering mold to be carefully released from the concrete surface and maintenance to be done by cleaning the cement slurry and oiling all the surface as per the instruction. Now, for the summary, the formwork, as we know, it's used as a mold and various types of the materials are used. Various techniques of the formworks are also used here. We discuss advantage, disadvantage, maintenance, de-shuttering here. So, I think this would be very much helpful for your student. Now, thank you.